Sometimes things just don't work the way you want them to. But if there's one thing I've learned over the past year of running this channel, it's that 3D printing can solve almost any problem. Whether it's organizing your space, keeping your toddler entertained, or my personal favorite, working on computers, being able to not just print objects but design them yourself can be incredibly useful. So that's why in this video I want to show you how easy it can be to start designing and making your own parts, especially if you're the type of person that watches this channel where you probably want to start making some cool adapters and upgrades for your PC or home lab. Take for example this budget PC case I picked up. It comes with room for 12 hard drives, making it potentially an amazing platform for a beefy DIY NAS or something. But, well, it turns out that it's just not that good. The tolerances were a bit off with the drive cage, so you ended up having to shove drives pretty hard just to get them in place. And that's not even taking into account how difficult it is to get the screws in. And since this is just a standard PC case with no backplane or anything, you would have to run a bunch of cables to the front, and well, that just wouldn't look great for a case with a glass side panel. But like I said, with the power of 3D printing, I don't have to settle for a subpar NAS case. First, I bought a couple of these little SATA backplanes, and then designed and printed 2 drive enclosures for them. These were able to just screw in place, and then with some 3D printed drive caddies, I could easily just slide drives in without having to worry about getting to awkward screw holes or run a bunch of messy cables. In the end, I had, in my opinion, a pretty awesome looking and very functional DIY NAS, and it only cost me a fairly modest amount of money and just a few hours designing the parts with a tool I like to use called OnShape. Now, I know some of you might be looking at all of this and thinking, well, sure, it was easy for you, but I have no idea how to just design 3D printable parts like that. And honestly, if I were watching this video like a year or so ago, I probably would be saying the same thing. But as it turns out, designing your own parts isn't actually that hard once you get the hang of it. I've only been doing stuff like this for about a year and a half or so, and it's become an invaluable skill that I use for way more than I would have ever expected. So if you want to, stick around and I'll show you not only how I designed this, but I'll also do my best to get you started on making your own designs using my software of choice called OnShape. I've found OnShape to be very intuitive and easy to use, and I think it's a big reason why I was able to just dive into designing my own parts not that long ago. So I'm really excited to say that, well, they're actually the sponsor of this video. OnShape is an incredibly powerful 3D design platform packed with professional-grade CAD and product data management tools, all in your browser. It's got real-time collaboration, full design history, branching and merging, built-in PDM, and even integrated CAM with their new CAM Studio. But despite all of that, it's still a great fit for hobbyists and tinkerers like me. There's even a free plan with access to many of the same tools, but just keep in mind that your designs will be publicly viewable. That's fine for me though, because, well, if I design something cool, I'm probably going to share it anyway. But OnShape clearly isn't just for hobbyists. It's a full-featured CAD and PDM platform built for professional teams. It supports secure, real-time collaboration so multiple people can edit a design at the same time. You also get full design history with infinite undo, plus tools like branching and merging to test changes without affecting your main project. Everything saves automatically and is always up to date, which means no file corruption, no installs, no updates to manage, and no IT headaches. And if you're working on manufacturing workflows, their new CAM Studio brings CAM right into the same platform with built-in PDM and collaborative tooling setups. I also love that OnShape is incredibly reliable, there's no crashing, no lost work, and since it runs in the browser, you can run it on just about anything. There's honestly so many other tools that I didn't even get to cover here, so if you're a professional looking to see what all OnShape can offer, you can get up to 6 months of OnShape Pro for free through the Discovery program. Just use the link down in the description to check it out. Now, I'm definitely going to talk a lot more about how to actually use OnShape here in a bit, where I'll walk through from start to finish how to design your own parts. But first, let's take a quick look at this project, why I made some of the decisions I made, and how it all turned out. So a while back, I had an awesome viewer send me a link to this case that they found, and I'm glad that they did because there's nothing in the title or the SKU that would have indicated that this particular version of the case has this 12-bay hard drive cage. I was quickly just skimming the product listing on my phone, and for some reason I saw these renders of these like black hard drive things and thought they were plastic drive caddies and thought, wow, what a cool little affordable case with some little caddies. And I just bought it thinking I'd make a video or something. But then, like I said, I actually got it and found that, well, I got what I paid for when it comes to that drive cage. Fortunately though, I found that that cage wasn't riveted in or anything. Instead, it was just held in place by a concerningly small number of screws. Because of that, I thought it would be pretty easy to just remove it and replace it with my own printed design, but, well, if I was going to go through the trouble, I might as well try to make it a substantial upgrade. So like I said, I found these SATA backplanes on AliExpress. These are just replacements for the Johnsbow N1 NAS case, and well, I'm not really sure if they're OEM or third party or what, but it didn't really matter for my purposes. Each of them have 5 SATA ports, so I ordered 2 for a total of 10 drives. And yeah, that's 2 less than the original, but I figured having 10 drives that are easy to replace is better than having 12 that I would just never want to hassle with. Once I got the PCBs, I designed a drive cage that they could fit into. To attach the PCB to the enclosure, you just insert a few M4 nuts, and then screw it into place. Now, this original drive cage just mounted to the inside of the case using some 120mm fan mounts on the side. So I just created some holes with the correct spacing, and then used these M4 heatset inserts so that I could just basically screw it in place like the original would have been. To help with vibrations and keep things a bit more stable, I also printed off some little feet and a flexible TPU filament, and these just sort of smush into place. Now, I couldn't just screw those drive cages into place yet, as I would need a way to get to the back side of the backplane. So I had to make a few cutouts on the side of the case for the I/O. That wasn't too hard to do with just a simple rotary tool though. After that, I just used a few more of those M4 screws to secure the 2 cages in place. Now obviously we would need a system to go in this, so I just put together a really simple build using an AM4 CPU and motherboard. Since I had 10 SATA ports to connect to, I also dropped in a SAS HBA, and then used some of these mini SAS to SATA breakout cables. With only 2 ports on the HBA, I could only connect to 8 of the 10 ports, so I also had to just use a couple of SATA cables connected to the motherboard. I also hooked up the 4 Molex connectors for power. Now, while PLA is probably the most common plastic that people 3D print with, a lot of people are going to say that you should print a drive cage like this in something called PETG or PETG, as it can handle warmer temperatures better without warping. And that is true, but PLA won't really start warping until you start getting into like the 50 degrees Celsius plus range or so. And well, if the outside of my hard drives are above 50 degrees Celsius, a slight bit of warping in the drive cage is the least of my concerns. So I ended up printing out the cage in some matte black PLA because, well, I just like the look of it. Now, the drive caddies were printed in PETG so that they would be a little bit more flexible, and they have these little clips on the side that help keep them locked in place. But whenever you pull this little handle, the clips kind of move in, so the drive can just slide out. And this honestly worked better than I was even expecting. Now, I didn't actually have enough drives on hand to put this build together, but fortunately Server Part Deals was kind enough to send over some 18TB loaners so that we can actually see this system in action. They aren't a sponsor of this video or anything, but it's where I like to buy my hard drives from, so if you're looking for some hard drives, they're definitely worth checking out. With all 180 terabytes worth of hard drives in this case, I got TrueNAS installed, and well, everything worked great. And not only does the system look pretty darn cool, it's practical, with drives that are really easy to replace. And it also wasn't terribly expensive. If you just stick to one color of PETG, you can actually print both cages and all 10 caddies with one 1kg spool. But if you also want to print those TPU feet, well, you'd also have to buy a spool of TPU. Then you also have to buy the screws and the heatset inserts, as well as the actual PCBs plus shipping. And then if you include the price of the case, well, the total's just a little over $200. Which, for a 10-bay NAS case with hot swappable drives, well, that isn't terrible. Now, there are a few things I would probably change if I were to redesign this, like trying to structure it in a way where there's a bit more airflow between the drives. Even still, after letting the TrueNAS system run for about 24 hours, none of the drives ever got above like 35 degrees Celsius. Now, you might have noticed that the drives are upside down, which is totally fine. That's because there wasn't quite enough clearance once I got it in the case for the drives to slide out with the edge of the little part of the case where the glass goes. So I ended up having to flip it upside down to give it a little bit more clearance, but it still works. And if you want to build this yourself, either in this case or in another case that maybe has 120mm fan mounts that this might fit into, I'll make sure to have links to all of the designs in the description, as well as links for the parts that I used. But hopefully you're curious about how to start designing models for your own projects, and as I've said, it's actually pretty easy to get started. Now, I'm not going to have enough time to make a complete tutorial on this entire design, so what I'll do instead is show you from start to finish how you could design something a bit simpler like this drive caddy. This should demonstrate most of the tools I use, and then after we finish that design and you're hopefully a bit more comfortable with OnShape, I'll briefly go through all of the steps I went through to design this entire drive cage. Now, you will need some things if you want to start designing and printing your own models. Obviously, you'll need a 3D printer, or at least access to one. To design things, you're going to need to measure things, and the best tool for that typically is a set of digital calipers. You can get these for fairly cheap, and I'll have some links to the ones I use down in the video description. You'll also want to make an OnShape account, which, like I mentioned, is totally free if you're just a hobbyist. The one notable caveat is that your designs are publicly available in a read-only manner, so just keep that in mind. Like I said earlier, I don't really care about that, but if you do, I know some people like to use obscure naming just to make it a little bit less likely that someone comes across their models. Now, assuming you have your calipers and your OnShape account ready to go, let's hop in and start designing stuff. All right, hopefully you've made your OnShape account, and if so, you should be signed in and end up in a little dashboard like this. Here you can see some of the designs I've made, but we're gonna go up here to where it says create, and create a new document. And here we'll just call this drive cage tutorial. Now, right off the bat, this is going to create what's called a part studio, as you can see down here at this tab here, as well as an assembly. We're not going to talk much about assemblies. Essentially, it's how you can take multiple parts and put them together and simulate motion and how parts work together. But part studios are where most of our work's going to be done. So we're going to stay within this part studio. And we can actually rename this, and we'll just call it Drive Caddy. And you can actually have more than one part in a part studio. Actually, that's kind of the better way to do things for the most part, but you also can split it up between different part studios, but we'll just keep it all within this one for now. Now, I'm not going to go through every single tool and panel that exists in OnShape. It would take a long time, but up at the top, you can see we have a lot of tools we can use. Over here, we can see essentially all of our different features or our changes as we design our project. And here we just have our default geometry, which is this origin point here right in the middle. And then we have our 3 default planes, one that's top, front, and then right. And then down here we have 0 parts because, well, we haven't actually created anything. Now to start, we're going to create a sketch. So we can go up here and click Sketch or Shift S, and then we need to give it a plane. And here you could technically start with any of the 3 existing planes, but we're going to select the top plane. And you can see now we have this little box for a sketch. Now a sketch is going to be pretty much what it sounds like. It's essentially going to be a little drawing with some dimensions, but more importantly, it's going to include constraints. And constraints is a little bit of a weird term if you're not quite used to it, but I think it'll make more sense as we go. So we're going to start by creating a sketch, but rather than creating a sketch of the actual caddy, if you're trying to model something that's going to fit around something else, sometimes it's actually easier to just do a simple model of whatever it is you're trying to make an adapter for. That way it's easier to sort of build our model. So we're actually going to make a sketch with our dimensions of this hard drive. Now you could break out your calipers and start trying to get the exact dimensions, but for something like a hard drive, well, those dimensions are publicly available because it's a specified standard. So it's actually pretty easy with stuff like this to pull up some documentation and get the exact measurements that you need. So here we can see that A3 plus or minus A11 is the width, and this A11 is just sort of a accepted tolerance. So really this A3 is the width. So A3 is 101.6, and then the length of our hard drive is going to be this A2, which is 147. So back in OnShape, we can just create a rectangle by going up to this little tool here, and we could create a corner rectangle like this, or we could do a center point rectangle, which lets us put our center point on the origin, and then go like this. And it really doesn't matter how big or small you make this, we can just click somewhere because we're going to provide these dimensions. All right, so now we have our rectangle, and if we want to give it dimensions, we can hit the D key or up here where it says dimension, and we can click this width here, and we'll say 101.6, and it's going to default to millimeters. And then here we can type in 147. And there is a sketch of a basic hard drive. And this is one way you can input dimensions, and it's probably going to be the most common way. But for something like the dimensions of a hard drive, which we might be referencing multiple times as we're building a hard drive cage, it might make sense to use variables here. So over on the right-hand side, there's this little variable table. And we can click this, and we could just put variables in right here. But if we want to access these variables across different part studios and assemblies, we can create a variable studio. And then right here, we can say something like hard drive width, and then hard drive length. And while we're at it, we can go ahead and enter the hard drive height. And then we can go ahead and actually enter those values. So for width, it's 101.6 millimeters. For length, it's 147. And then for height, it's 26.1. So we can close this variable table here. And then back in our dimensions, we could actually change this 147. And instead, we could just put a little hashtag, or you could just type in HGD underscore and then find the length and then hit enter. And you'll see it still says 147. And then we can do the same thing for the width. All right, so now we have this sketch, but it's just a 2D sketch. We need to give it some volume. And so what we can do is we can just select this little face here of this sketch we created. And then we're gonna go up here where it says extrude, or you can hit Shift E. And as you can see, it's already kind of doing what we were hoping it's going to do. It's going to take that sketch and extrude it to create a 3D object. Now here we're just doing what's called a blind extrude, which just means it's going to go from that sketch and go up, or we could technically click this little arrow and go the opposite direction, but we're going to stick with that. And for the depth, we can once again just use our variables here. So we can go to hard drive height and hit enter, and then we'll hit this little green check mark. And there we go. We have our hard drive. And as you can see down here in the parts list, now that we have a 3D object, we actually have our first part. Now here I'm going to actually rename this. So you can right click and hit rename, or you could also hit Shift N, which is a really helpful shortcut to remember. And we'll just call it hard drive. And if you don't like that this is blue, you can actually right click it and go to Edit Appearance, and we'll just make it gray. All right, cool. So we have our hard drive, but hard drives are more than just a big block of metal. They have little things like the SATA port, which we're not going to worry about, but more importantly, they have these little screw holes. So we're going to model those. Now, once again, we can just reference these specs to get the dimensions between these holes, but how do we actually make holes on the hard drive? Well, to do this, the easiest way is probably going to be to create another sketch. But this time, rather than using one of these default planes, actually we can hide these over here on this thing here. We can hit this little eyeball icon to hide these. Rather than using those, we're going to need to use a different plane to create our sketch. And the plane that makes the most sense is this side right here. Also, I'm right clicking to move around in this window. And you can also click this little icon up here if you want to look at a certain face. So we're just going to look at the left side. We're going to assume that this is the front right here because it says front. If we go to the left side, we can just click on this face. And if you notice that you have multiple things selected and you want to deselect them, you just hit spacebar. So I want to select just this face here, and then we're going to hit sketch again. And now you'll see our sketch is actually taking place on this face, this side of our hard drive object. All right, so here we need to make a sketch for the holes. And I can actually rename this sketch. We'll call it hard drive holes, just so we can stay a bit more organized. And over here on this first sketch, we can hit Shift N to rename this as well to hard drive, we'll say like hard drive base. All right, so we'll go back to our hard drive holes sketch. And now here we need to create a couple of holes, or just circles really. So we're going to hit the little circle button here, and we're just going to create 2 circles. It doesn't matter how big they are or really where they're at. We're just going to kind of roughly point them where we want them to go. And we didn't really talk much about constraints in that first sketch, but you can see right now that these circles are blue, which means I can make them bigger or smaller, and I can put them wherever because there's no constraints. There's nothing there to say this is where those holes need to be and this is how big they need to be. So we need to create those. So first we're going to give it the height from this bottom of the hard drive up to the center of this first hole. And as we can see, that's this 810 value, which is 6.35. So we can hit the D key or hit this little dimension button up here, and we're going to select the center of the circle and then this bottom line of the hard drive. And now we have this nice dimension, and we can give it that value, so 6.35. And now if we try to slide the circle around, I can move it left and right, I can make the circle bigger or smaller, but I can't make it go up or down, and that's because we have this constraint here, which is just this dimension of 6.35 millimeters. All right, the other dimension we need is this A8, which is the distance from the front of the hard drive to the center of the first hole. And that is going to be 28.5. So we can go back here and we'll do the D key again for dimension, select the center of the circle, but then we're going to select this line at the front. And I already forgot the number, 28.5. Okay, so now this circle cannot move. I can make it bigger or smaller, but it can't move. All right, now the last thing we actually need to define for this circle is the diameter. So we can hit D, and then we can just click on this circle to give it a radius. And we don't really have to have the exact diameter here for the 632 screws that are used for hard drives. We can just have something kind of close. So we're just gonna type in 3.5 millimeters. All right, and now you'll see that the circle, it's not black, it's white because I'm in dark mode, which is kind of a new thing for OnShape, which is cool. But you can see this circle is no longer blue, it's white. Or if you're in the light mode, it'll be black. And that means this circle is fully constrained. There's no guesses about how big it should be, where it should be, it's fully constrained. But this other circle, well, it's just not constrained at all. It's just floating off in space and it can still be made bigger and smaller. So we could use some more dimensions and create specific measurements and copy paste this height dimension here, but that starts to get really messy over time and you'll have tons of dimensions everywhere and it can just be really messy. So instead we'll use some other constraints. We have lots of options up here at the top. So the first one we're going to use is this equals constraint, or just the E key. And basically how this works is you just click the diameter of the first circle, or you just click the first circle, and then you click the second circle, and it's going to make the diameter the same. So this circle can no longer get bigger or smaller. It can just move around. Now the other constraint we can use here to keep things a bit simpler is rather than duplicating this 6.35 diameter for the height, we just want this circle to be at the same horizontal plane as the first one. So we can just select the first dot, and then the second dot, and then we can just click this horizontal button or the H key. Now, once again, the circle can't move up or down, it can only go left and right. And here, because we have to have a specific dimension between these, now we would actually have to use the dimension tool by clicking D and then typing in 101.6. And now if we look, there's no more blue on this. It is fully constrained, which is what we want. So we can hit the little check mark. But we need to actually do something with this sketch. We need to make some holes in this hard drive. So once again, we're going to select this sketch, and then we're going to select Extrude. And as you can see right here, the faces to extrude, it sees faces of hard drive holes because there's multiple faces. We have our 2 circles. Those are the 2 faces of the sketch. And as you can see, it wants to extrude, but we don't want to have these pegs sticking out of our hard drive. We want to actually make some holes inside the hard drive. So to do that, we're going to change the mode here from add to remove. And instead, this is now going to go the opposite way. And as you can see, it's kind of burrowing in. And then we can give it a depth, and we're just going to say like 5 millimeters. It really doesn't matter here because we're not actually trying to screw screws into this hard drive. This is just a reference point for our caddy we're about to make. All right, cool. So we have some holes that start to look like a hard drive on this side at least, but if we go to the other side, we don't have any holes there anymore. So we want to fix that. Now we could go make another sketch on this plane and create a new sketch, but that starts to get really messy. We'd have a bunch of duplicate sketches that don't really make sense. So realistically, what we're trying to do is we just want to do these exact same holes. We just want to mirror them onto the other side. And fortunately, there's a handy tool called Mirror. If you go up here to the top, you can see there's this mirror tool. And here we don't want to mirror a part. That would be like the whole hard drive. We want to mirror a feature. So we're going to select feature. And so now the features to mirror, we can select Extrude 2, which is our whole extrude. But then we need to give it a plane, that way it knows what to mirror it across. And so we need to actually make our planes visible again. And so as you can see, this right plane is right in the middle of this hard drive. So for our plane, we can just select the right plane. Oh, I have to select this little mirror plane thing here and then click the right plane. And now you see nothing's red anymore. And if we go on this side, we can see we now have our holes on the other side of the hard drive. Also, if you ever try to use the mirror feature and you get like weird things where this is red and it doesn't want to work, but it makes sense like it should, try checking this reapply features button and sometimes that'll fix your issue. All right, but we're all good. We can hit this check mark. And now we have our hard drive with all 4 holes that we need, which is pretty darn cool. We're not going to model the SATA port or anything because we don't really need that, and that would start to get really complicated. Instead, we're going to go ahead and move on to creating our hard drive caddy. So I'm going to hit this little top button, which is going to get us back to this top view, which is really handy. And if we think about how this hard drive caddy should work, it actually, the bottom of it exists on the same plane as the bottom of the hard drive. So we can actually start a sketch for our hard drive caddy by just selecting the top plane and creating another sketch. Oh, actually, I'm going to do something else really quick. One thing we can do to kind of clean up all of our features over here is create a folder. You can actually see there's a folder already for the default geometry that you can toggle open and shut. So we're going to create a new folder here and just call it hard drive. And then we're going to select all of our hard drive features and put them in that folder. Put them in that folder, sorry. And then we can close this folder because we're kind of done with the hard drive. So now rather than having all of those features that we created, we can have a kind of a nice clean slate to start with. All right, now we'll select our top plane and create a new sketch. And we can go ahead and rename this right now. We'll just call it Caddy Sketch. And I'm going to just hide our default geometry. So as you can see, we're starting a new sketch, but we now have this hard drive here that we can actually use as a reference point, which is really helpful. All right, so if we take a look at the hard drive caddy, up at the top, we don't have anything that's blank so that it can actually plug into the SATA port. And then we have these 2 rails that go all the way down. And then there's this little handle that kind of comes across that we can pull on. There's also these little tabs, but we're gonna do those in a separate sketch. So we'll get to that. We're just gonna get the base shape of this started, and then we'll go from there. So what I can do is I'm just gonna grab this line tool. And okay, so this is the front of the hard drive. And what I'm going to do is I'm just going to start kind of creating this sketch. So I'm going to click on this line. And as you can see, there's this little, it's kind of hard for me to point at because it'll go away if I try to point at. You can see this little icon pop up that has like 2 lines with a dot. That's just saying that this is going to create a coincident constraint, which is helpful because I want this to be basically touching that line. And then I'm going to go across, and you can see here there's another icon to create a horizontal constraint, but if I move my mouse up, you can see that goes away. So this is just going to create some default constraints, which can be really helpful. So I'm just going to draw a line out to here, and then I'm going to go up to the top. I'm going to go a little further out. And then, as you can see here, it's going to create some constraints here to basically make a rectangle. And I'm actually just going to stop there. I probably could have just used the rectangle tool for that, All right, so I created some of these variables here that I just pulled from my original document, and so we'll be able to use these really quick. So if we're going to close the variable table, and I'm going to start creating some constraints here. So I could select these 2 points again with the dimension tool to create a dimension, but an easier way to do it would just be to select the line. And here I'm going to say Caddy rail width, which is 5 millimeters. And then I also have this offset value, which is basically the distance from the end of the rail to the end of the hard drive, which is just to give a little bit of clearance so that this rail doesn't actually touch any of the components that are on the PCB. And that's just 2 millimeters, but we can say Caddy rail offset, hit enter. And we're not going to deal with the height yet because that's going to happen when we actually extrude the drive caddy. And then the only other dimension we don't have is how long this should be. And for right now, I'm just going to give a little bit of a dimension here. So I'm going to say, oh, not an arc. So I'm just going to select this line here and this point, and we'll just say like 10 millimeters or something. That might change here in a second. I want this rail to be on the other side though. So just how we did a mirror with a feature back in the 3D viewer, we can also do a mirror in the sketch. So we can do this mirror tool, but we need a line to mirror across, and we don't actually have a line somewhere that we can use as a mirror. We could once again bring up this right plane, and we could select this and it would use that as a line. But instead, I'm going to show you how to use construction geometry. So basically I'm going to press L or just click the line tool up here, and I'm going to go to the middle of this hard drive. And if you see, if I get right in the middle of this line, I'll get this little midpoint constraint, and I want that. That's going to be right in the middle of this line. And then down at the bottom, I can grab the other one. And so now I have this perfectly constrained line that's going right down the middle of our hard drive geometry. But I don't want this actually to be a line that's used in any sort of extrude or any kind of feature. I just want this here as a reference point. So if I select this line and hit Q, I'm going to turn this into what's called construction geometry. You can see the little tool up here for that. So now you can see that this is a dotted line, which means it's not actually going to be used for anything except as a reference point. So now if I go back to the mirror tool and select this line, that's going to be my mirrored line, and then I can just start selecting any entities that I want to be mirrored across that line. Cool. So now we have these sketches, and as you can see, there's no blue, everything is perfectly constrained, so technically we could come out here and click this sketch and do an extrude and start creating a drive caddy, but we need this little handle across the middle. So we'll go back to our sketch, and for this we want to have a nice little arc. And now really quick, I'm actually gonna add a little bit more here. I'm gonna say 14 millimeters, I think that's actually the value that I used in my original. I'm actually going to change this to 12. I went and looked at what the original value was. It was 12 millimeters. And what's cool is you can see as I change this, the other side, since it's a mirrored constraint, is going to change as well. So 12 millimeters. Okay, now I need to create a nice little arc that's going to go around from here to here. So I'm going to select this arc tool. And there's a few different versions. There's like a 3-point, there's a tangent. We're just going to select the 3-point arc. So basically we're going to select our first point here, and then our second point here. And then we can move this, it's kind of hard to see, but you can see there's this third point down at the bottom that's actually what we're defining here. So we're just going to create this shape to look somewhat similar to what we want it to look like. And we'll click that, but as you can see, I can still move this point here around. That's going to change our arc shape. I'm just going to leave it right around there for now. And then we want to create another arc that's going to go across. The issue here is that, well, I don't want this handle to actually be 5 millimeters thick, because that's going to be really thick. I think with this original, this is 2 millimeters thick. So we're going to have to make a couple changes here. And what I'm going to do here, once again, is just select this line tool, and I'm going to zoom in here and create a little line here. We're going to go straight down, and then go across something like this. This isn't great, but this probably isn't the best way to do some of this stuff, but we're just gonna make it happen. I'm gonna make this width 2 millimeters. And it really doesn't matter what this dimension is. Let's just make this like 4 millimeters. All right, and then we want to, there's a couple ways I could do this. I'm just gonna make another mirror feature here. So I'm gonna select this line, and then I'm going to select these 2 lines that I made. And then I'm going to select this trim tool, or the M key, and I'm going to trim away these little lines here. Now, sometimes when you do stuff like this, you might get, so like right there, I had some reference geometry. So on this point here, I had this this dimension here for 12 millimeters. So if I trim this away, I lose that dimension, and so I'll start to get stuff that's blue. And so what I'm going to do now is just create a new reference point here, and we'll say this is 8mm. And now we should be good. And I can trim this away too. Okay, so now everything is constrained once again except our arc. And we're actually going to create a separate arc, or a second one. And we're going to make it from this point over to this point. And so now we have this arc, but it looks a little funny because the thickness is weird. And once again, we can kind of move these around and get weird stuff going on. So we want to make some more constraints. So what I'm going to do is I need to set up a radius for one of these arcs. And there's a few different ways I could do this. I could actually just like, if I constrained this point here to be coincident with this dot, that would actually lock that radius into 57 point whatever. We don't want that. But I'm actually going to use the dimension tool here. So I'm going to hit D and then click on this outer arc. And as you can see, this is actually going to create a radius. This is essentially treating this as a big circle. That's actually how this arc is being created, is it's just a portion of a circle. That's what an arc is, math, whatever. We're going to set this radius to be 115. I think that's actually the value I used in my original one. And this, it really doesn't matter. This is just kind of me coming up with what I wanted this to look like, and it ended up working pretty well. Some of this, at least for someone like me, is just guesswork. All right, and then for this second arc, we're just gonna select it in the original and hit E, or the equals constraint. And so now we have these two arcs that both have the same diameter, so we get this nice shape that goes around the side like that. Oh wait, no, I realized this is not what I wanted. I want, so part of the problem is this right here, this dimension here. This shouldn't be for this line. So I'm actually going to delete this constraint there. I want the distance between this point and this point to be 8mm. But I don't want this line to be horizontal. So I can actually click this. I can click this horizontal constraint and hit delete. I actually want this to be able to come down a little bit. That way this thickness can be correct. I knew I did something wrong here. And so now we have these are an equal radius, but we want the distance between these to be set. So we can hit D and then click between the two. And now we can set this to 2mm. And that is what I was trying to do. I accidentally had this horizontal constraint here that was throwing me off. Cool, so now we have this little band that goes around it for the handle that's 2mm thick, and we don't have anything in blue, so that means our sketch is fully constrained. So we'll hit the green check mark, and then we'll select the sketch, hit Shift E to extrude. And then for the depth, I already have a variable here, so we can do Caddy rail height, hit enter, and there we go. But if I hit the green check mark, well, you'll see this hard drive Caddy rail is the exact same color as our hard drive. And if we look down at our parts, we only have one part. We don't have a new part for the Caddy, and we want to fix that. So back in our extrude, we're going to change this mode from add to new. And what this is going to do is it's actually going to create a new part. And so now if we hit this green check mark, the colors still look the same, but we have two parts down here. So we could go down here and hit Shift N to rename this. So we'll name this Caddy, and then we can edit the appearance, and I will make it kind of a yellow to match what we have going on here. All right, cool. So we now have the basics here of our hard drive Caddy. If we get rid of our hard drive or we just hide it, we can see this looks pretty close to what the final product's gonna look like, but there's a few more tweaks we need to make. The first big one is that we need to create the holes to actually screw this in. So once again, what we could do is we could go here, we could make a sketch, and then we could try to pull up those same exact dimensions we got from the Western Digital site, wherever I found it, to create these screw holes. But part of the reason we created that hard drive in the first place is so that we didn't have to do that again. If we go back here, we can create a new sketch on the side of this, but rather than having to put in those dimensions, what I'm going to do is I'm actually going to just hide this hard drive Caddy really quick. And we can see our sketch we're working on this plane, but now we can actually see the holes behind this. So we can use that for reference. So what we're gonna do is just create two holes. Once again, it doesn't matter what they look like, just two circles. And then all we're going to worry about doing is matching up this center point here. So we can select this little center point, and we want to match that up. Which I'm realizing now that there's not a point on this because we don't have the sketch shown. So we could bring up this sketch here, and then we could use this dot here, click that one, and then hit I to make them coincident, and now you can see that's lined up perfectly. Another thing we could do if we didn't want to bring that sketch back up is just click this circle, click this circle, and hit I to make them coincident, and now that'll actually make them the same size and in the same location. So that would be really easy to do. Let's just do that. All right, there we go. We have our sketch for our holes in the hard drive Caddy. I could bring that back up. But as you might remember, we didn't make sure that these original holes were the correct dimensions or anything. They were just kind of a rough estimate. But that's okay, because instead of selecting this sketch and going to extrude and remove and doing something like that, we're actually going to use the hole tool. There's actually a specific tool just for making holes, which is really handy. So you could go up here and try to find it, but if you're struggling to find a specific tool, you can always search. So we're just gonna type in hole, and we can click that. And so now we have our hole tool here. And so what we can do is we need our sketch points to place the holes, and we don't need these circles, we actually just use points, and this will automatically handle the holes for us, which is really cool. Now this does get a little bit tricky with the hole type and like drill sizes and counterbores and countersinks and stuff like that. We're just going to select this hole type clearance, and then we know that the screws for hard drives are 632, so we should be able to just go to number 6. And now we see this diameter is 3.658, and that's a close fastener fit. We want to go to free. That should make it a bit bigger, and that should make it easy for the screw to actually just go through. But we don't want to have the screw head sitting on top of this drive sled thing because then it won't actually go in. So we're going to do a counterbore. And now I have to reselect all of my stuff I just did. And then this is looking pretty good. We should be able to get our screw to go in there. If you want to make sure that that counterbore diameter is wide enough for your screw head to actually go into, you could take your calipers. I can see that my screw head is 5.65 millimeters in diameter, which as you can see here, this counterbore diameter is at 7.14, which should be plenty. And then for the depth right now, it's at 0.138 inches or 3.505 millimeters. I want to say this all looks pretty good. I don't think we need to change anything. That should be fine. Like I said, the whole tool can get pretty complicated. You can do some really cool stuff with it. So a lot of times I just default to doing removes with extrudes. But then if you want to have these little counterbores, you have to come back and do some more stuff. And so that can get a little bit annoying. And so now we have our holes, but once again, we don't actually have those holes on the other side of the caddy. So the easy fix here is just to select this and then go up to mirror. We're going to mirror a feature, which is this hole. And then for our plane, we can do this right plane. And then, like I said earlier, sometimes you get this little red thing going on here. We're just gonna hit reapply features and then hit the green check mark. And there we go. All right, so now we have our drive caddy with the screw holes, and realistically at this point, I think this would actually work just fine on my model, well, minus that we don't have these little clips. So let's do that next. We're just gonna create another sketch. We can do it right here. And then I'm just gonna make a little rectangle somewhere like that. All right, so I copied in some of these variables from my main project and then just created these dimensions. So I have these offsets for how far from the end of the hard drive it is, and then how far from the bottom of the hard drive, and then the dimensions for it. And so we can just save this sketch, and then we're just going to extrude this once again. And I have a depth variable here for the clip. And there we go, but well, it's just a block. It's not this nice little kind of triangle shaped clip thing that it should be. So to fix that, what I did was create a chamfer. So up here, there's this chamfer tool. We can click that. And then we need an entity. So I'm just gonna select this line right there. And so that's going to create this nice little chamfer or kind of a beveled edge, but that's not what we want it to look like. And there's a few options we can do for the chamfer type. We could do equal distance. And so if we said 1 millimeter, this is going to be a 1 millimeter chamfer right there. But we don't want this to be a 45-degree angle. We want it to be a different angle. So we're gonna do 2 distances. And so if we type in just like 1 millimeter here, we can see that this distance is 1 millimeter and this distance is 5. Well, it's trying to be 5, it can only be 2. If we change this to 2, it should look very similar. We want this distance to be longer. We want to change this to the clip depth, which is 2. And we want to change this first distance to the clip length, which is 7. And so now basically that makes this nice, smooth little triangle. So we'll hit the green check mark there. And there we go, but we only have 1 clip. So once again, we need to mirror. And so what we can do is we can hit the mirror tool. We can select our mirror plane as this right plane. And then for entities, we're going to change this to feature. And then if we selected this chamfer, we have this issue because there's nothing here for it to chamfer. So we can't mirror that chamfer by itself. Instead, we need to mirror this extrude. And then if we hit reapply features, that should look good. But then we can also mirror this chamfer. So we can mirror both of these features at the same time to get this nice little clip on both sides. We'll hit the green check mark. And there we go. We have our clips. And really all that's left is some nice finishing touches. So for example, there's a little chamfer I put on the end of the hard drive caddy just to make it easier to slide it into the cage. So to do that, once again, we can just create a chamfer and then we'll zoom in here to this right there and we'll select that. And we'll do like a distance of 5 and 10, why not? Cool, that we'll make it a little longer. We'll do like 18. Cool, and if we wanted to, we could actually mirror that on the bottom to make it even easier to slide it in, although we'd probably at that point do something like 3 or something. The problem with doing this is that since you are going to be 3D printing these parts, I'm assuming, you have to kind of design your parts in a way that you think is going to be 3D printable. So right now this should work pretty well. These circles might need supports, but really you should be able to print bridges across these and be fine. You might need supports for these little clips, but that's kind of inevitable just with the design I went with. But here, this is going to be a little difficult to 3D print unless you use supports. So you could use supports, or you could just say, you know what? I'm just gonna have this chamfer on this and not do it on the bottom. And so we could do that. We'll do it here. And then, oh, all right, so this chamfered edge looks right, but this one looks, it's wrong. It's using the wrong directions. And so what we can actually do is we can go to this directions override and select that edge we were chamfering, and it'll just reverse the edges. So that'll fix that. We could also select this edge. If we wanted things to get crazy, we might have to adjust our values. We could do like 2 here maybe. You could chamfer this to make it kind of easier to get in as well. And you know what? We're just gonna do that. We could maybe change some of these values to do 2 different chamfers, but for the most part, that should get the job done. It should make that little tray easier to slide in place. So we're just gonna call it good. Now we may also wanna create a little bit of a chamfer here. You could do this with a countersink in the hole tool, but I don't think you can do countersink and counterboard at the same time. So we might want a little bit of a countersink here for our screws if you're using like tapered head screws. So I'm gonna create a little chamfer here, and we're just gonna do an equal distance. Yeah, we'll just take 0.8 millimeters. Just something a little bit just to make those tapered head screws a little bit easier to screw in there and sit a little more snug. And we'll just select all of our circles and then hit the green check mark. So now we have these nice little countersinks as well. It's looking good. Now, there's only 2 more things we haven't really gotten to that this design has. First of all, there's this little cutout here to make the handle a little bit thinner, so it's a little bit easier to kind of get in there and grab. So we'll do that. And then also some of these little edges on the inside are rounded just to kind of relieve some of the kind of stress points when you're pulling on this. So we'll create those as well. So first, let's just create this little cutout, and it's going to be hard to put a sketch on this curved surface. So instead, I'm just gonna select this surface here, and then we'll make a sketch. And I'm just going to kind of eyeball this. We're gonna create an arc. We're gonna go across, and then we're gonna make it go down like this. And I wanna bring this down a little bit. We can keep it on this line here, and we're just gonna make these 2 edges coincident. So I just hit the I key. And then on this side, I could also make these coincident, this and this line coincident, or I could just select that point and this point and hit H to make them horizontal. And then we're gonna give this arch a radius. So I'm just gonna hit the D key, click that. Okay, that looks about kind of how I want it to look. And then we just need to, honestly, we can just make a little box like this, go around, and we'll give this a height of like 10 millimeters. It really doesn't matter. And so now we have this sketch. What I'm gonna do is I'm gonna click on it, and then I'm going to go to Extrude and Remove, and we'll just change the direction so that it comes out. And you'll see now though that when I'm trying to remove from here, there's no intersect. And that's because right now our merge scope is with the hard drive part. So we're gonna deselect that, and we're gonna change our merge scope to be the Caddy. And there we go. Now this extrude is going to merge, this remove extrude is going to merge with this Caddy. And that's creating what I want it to create. You could play around with this depth here. Another thing you can also do is rather than doing a blind extrude, you can do like an extrude to face. So you can do up to face, and then we'll select this face, and it'll automatically extrude just up to that face, which is kind of cool. And there we go, there is that. But like I said, there's these little corners right here that are these sharp edges, and that's possibly a point that the plastic could like crack if you're pulling on it. So what we're going to do here is just smooth these out. And the easiest way to do that is just select this line, and then we're gonna go up to the fillet tool. And the fillet is kind of like a chamfer, but instead of creating a straight edge, it's gonna do this nice curved edge. And then we can tweak the diameter to make it bigger or smaller. We're just gonna do like 2 millimeters. Actually like 3. 3 looked pretty good. Let's see if it worked for this one too. Okay, cool, it worked for that one and that one. Then we'll select this one and we'll select this one. And now we can hit the green check mark. And now we have these nice smoothed out edges. And then another thing you could do if you wanted to get fancy is just select these top faces, go to fillet again, and then we'll have to make this really small. Let's do like 0.75. And as you can see, this is actually gonna smooth out all of those top edges to kind of just smooth everything off. You don't have to fillet everything like this, but sometimes you can just kind of make your parts look a little bit better and actually kind of make them work a little bit smoother. So yeah, there is our hard drive caddy. It's looking pretty good. So now if we wanted to actually print this out, what we could do is we could go right down here to the part and right click this and hit export. And most of these settings should be good. You can give it a file name that you can change when you save it. The format, so we're gonna do STL. And then all of this should be good. We're gonna hit export. And then now I'm gonna call this tutorial caddy and we'll hit save. And then in my Slicer Bamboo Studio, I could grab this tutorial caddy STL, drop it on here, and yeah, it's ready to print out. Pretty cool. That's our drive caddy created from scratch. I'm assuming it'll work pretty well. And these are pretty much all of the tools that I use to create the parts that I do and all of the tools that I created the entire drive cage with. And speaking of that, let's hop back into my original design. And now we should be able to kind of go through step by step of what I did. And hopefully you have a good understanding of what I was doing. And it might give you some insight into how you can create your own designs. So this is actually the document for my original design. And if we go down here, you can see I have this hard drive caddy. Pretty much, this is the exact same thing almost that I did with you guys. I did 3 drive holes and some small tweaks are a little bit different, but it's basically the exact same thing as what we just did. I also have this PCB file here, and this is where I just created a model of the PCB for reference. So basically, I just have this sketch here called PCB, where I used my calipers to measure the width and the height of the PCB. And then I figured out the holes as well as this spacing between them. And then I used the calipers to measure the diameter of the holes and also get approximate measurements for where those holes were placed. But yeah, I created this. And then I did an extrude just to create the base of the PCB. Then I created another sketch to actually sketch kind of the rough dimensions of one of the SATA ports on it. And then I did an extrude for that just to get a rough idea. This doesn't look like a SATA port, but it was enough to get the outside dimensions and then also be able to line up the little pins on the inside for the next part. And then I did a pattern just to create 5 of them with the correct spacing between. And then I was going to model all of the stuff on the back of the PCB, the little capacitors and the IO connectors, but instead I just kind of created a little boundary of where all those would be so I could create this third extrude that was another part that I just called clearance. That way, as I was designing things, I could make sure I didn't have anything that was going to overlap with a capacitor or a Molex connector or something. Oh, okay, here's one thing I didn't talk about. There's this Boolean here, which Booleans are basically ways that you can kind of like add or merge parts or subtract parts. And it's something we didn't touch on with the hard drive caddy, but essentially what I did here was I had created a bunch of these little SATA objects, these little SATA port parts that were all individual. So I use this Boolean here basically just to merge all of these into one part that I think I actually got rid of here in a little bit. The next thing I did was I created this extrude here on top, which is basically just the sketch minus these SATA ports. And you can see here I actually made a new object that I called test fit. So if I just look at this little test fit part, and basically this was just kind of a negative of the PCB that I could print out. So I ended up printing out this little test piece that I could slide over just to make sure all of my tolerances and placements were correct. And I'm glad I did because, well, I ended up having to print off 2 because I had to make a few small tweaks to my measurements. I had a couple more Boolean operations and a delete part operation just to kind of clean some things up. And then here at the end, I just had this Boolean to merge the PCB and all of the individual SATA parts into just this one part 9, which I probably should relabel to something more useful. There we go, this PCB and SATA. So I had one part that was all the individual parts kind of combined that I could use for reference. Now I have this drive cage part studio. You can see I have my finished drive cage. And here I actually started out with this derived, which this derived basically is just a way that you can bring in parts from other part studios. And it's really cool because if I were to go in and make changes to the dimensions of the PCB, like let's say I had one hole that was off by 2 millimeters and I designed the whole cage around that and it was wrong, I could just go back to that PCB file, fix that measurement, and that would actually get reflected on this derived PCB object in this other part studio. Then I created a sketch that I created this sketch on top of this clearance object, just so it would start at the very back of where all the ports and everything were. As you can see here, I just had this sketch kind of creating the back of what this cage would eventually look like with some different measurements to be able to put some holes and things like that. Then I extruded that out just a little bit up to a certain point so that I could bring in this other sketch to create the screw holes for the PCB. And then I just did an extrude here to create those holes. Then on the back, I had a sketch to create these little hexagons for another extrude that was for the little hex nuts. And then I had one more sketch on the back for the holes for the heat set inserts. And then once again, I followed that up with another extrude that was 10 millimeters deep, which is the length of those heat set inserts. So that was everything for what I called the base in this folder. So then for the rest of the cage, I created another sketch so that I could then extrude up without extruding this kind of base portion. So just the cage around where the hard drives would go. Oh yeah, so this sketch is kind of weird. I actually needed to add a little bit of thickness to the walls here so that the hard drive cages would be wide enough to not just like fall out. But if I added this and made the thickness, made like that extra extension go all the way down, it would actually cover up parts of the PCB and make it impossible to get to the little screw holes. So I did an extrude here, but rather than extruding all the way down to the base, I just extended to a certain spot and I had a bit of an offset. So you can see it only extrudes, so it's kind of hard to see, but it only extrudes so far. And then to kind of smooth that out, I did a chamfer, kind of how we did before. So you can see there's this slope here. It's really hard to see with some of these extra lines. So yeah, you can see I did a little bit of a chamfer here so that you can see there's a little bit of a slope. So that way up here at the top, it's thick enough that the drives don't like kind of fall out, but you can kind of get your way down to these holes and the PCB can fit properly. Then I did what's called a move face, which is kind of weird. Essentially what you can do is you can select a face and then you can go to this move face tool. And then basically you can just take that face and like extend it or cut it off, which can be really helpful for like, oh, I got this and it's close, but it's a little bit off. I need to like just extend it like 2 more millimeters or something. And that's basically what I did here. I just took this and I realized some of my math was a little bit wrong with how long it needed to be. I realized I needed to add like 18 more millimeters. And so I just added 18 more millimeters to this original extrude. All right, and then I started creating sketches for the actual hard drive trays to go into. And so as you can see here, I just did an extrude to cut it all the way down to a certain point. Then I just did a linear pattern to create 5 of these that are correctly spaced with this SATA port offset value. Then I also created this little sketch to create the holes for the clips. So as you can see here, I created a little hole. And then once again, I just used a linear pattern to create all of those holes. And then to copy those little clip cutouts over to the other side, I just used another pattern, another feature mirror like we did before. But here I actually had to create a new plane using this plane tool to create a plane here that was directly centered between well, where the hard drives would go. And then basically all I really did after that was create some sketches for these little hexagonal cutouts that then I could extrude. And after a few more extrusions and some patterns, I ended up with these cutouts for some airflow. And then with this very last move face, basically what I did was I just grabbed all of these walls here where these little hexagon patterns are, and I just tried to move them out ever so slightly just to create a little bit more space to try to have a bit more airflow. And yeah, that's the end result for the cage. And as I mentioned, this is in a part studio, so is the hard drive caddy, and so is the PCB. Technically, I could have put those all in the same part studio, but I kind of like splitting them up and then using the derived feature to kind of bring those parts in, just so I don't have a million features over here in this features window. All right, and the last thing I wanted to show you was we talked about part studios. So if I were to go down here and create a new tab, I could create a new part studio. We also talked about variable studios. We actually created one of those for all of our variables. But I could actually also create an assembly, which I have right here. And basically here you can just bring in components. So I could bring in something like, oh yeah, I could select this feet part studio and I could just bring in a foot. And so what I could do now is create a mate connector, which for this, I would use what's called a fastened mate because it's not going to move. And so I'm just going to create a mate connector there. And then on this hole, I'm going to create a mate connector there. And then I could flip some stuff around. That's not the greatest example. I don't use assemblies very often, so I'm not very familiar. But I could basically make a little connector there to kind of stick these together into an assembly. It's not very useful to do with static parts like that, but you can also use like a slider mate like here to create stuff like this, where you can actually like see how your parts are going to interact with each other. Like I said, I don't really use assemblies a lot. I don't find it all that useful, but you might with your parts, who knows? So yeah, that is OnShape. That's pretty much how I design my ideas and create parts for videos, but also just for like everyday life. There's been so many instances where I have some idea of like, oh, I want this thing to make my life easier. And so then I take that idea, I go in OnShape, I throw something together, I print it off, and then I just have it, and it's so cool, and it's been really useful. So hopefully you guys learned something and can take this and start creating things of your own. If you're wanting to learn more about OnShape, I know this was a pretty like high level, there's just a lot of information kind of all at once. So if you guys want to learn some more, I'll have some links to some great tutorials and creators that make videos on OnShape and design and that sort of thing. I'll have those down in the description. And yeah, I think that's pretty much it. So thank you guys so much for watching. Stay curious, and I really can't wait to see you in the next one.